All right, we're doing the next section of confidence intervals, but I got a special guest today.
Hi, this is Jerry.
There we go. If you want to see him, maybe he'll make a little cameo appearance in a minute. But what we have going on here is I have this information that says a Gallup poll, a Gallup survey. They did a youth survey and they asked a random sample of 439 U.S. teens between the age of 13 and 17 whether they thought young people should wait for marriage. So of the sample, 246 said yes. What we're going to do is I want you to construct, or we are going together, going to construct and interpret a 90% and a 95% confidence interval for the proportion of all teens who would say yes. So again, we know a sample value, 246 out of 439. What we don't know is we do not know what the actual proportion is for all teens. So we're going to make an interval and take a guess at what that is. And that's basically what a confidence interval is. It's a best guess. So here we have, says, estimating a proportion. That's like, in terms of the state plan do conclude. That's the state portion there in red. All right, so we're going to state that I'm going to be estimating a proportion. All right, and then my plan, here's my plan. All right, this gets to the four conditions. Are my four conditions met? S. This is stated to be a simple random sample. I got to write the words out. For the I condition, now if you want to have the I on there, you certainly can, but you don't need to. So I write 10n equals 4,390. That's 10 times the sample size. There are over 4,390 teens in the U.S., therefore independent. It's that idea of, and I didn't write it down because I don't want you to get in the habit of just writing the formula, but capital N greater than 10n. N, normality. Can we show normality? So we go n times p. N is 439 times 246 out of 439 is 246. So really NP is how many successes? Is that at least 10? Yes. How many failures? NQ, 193. So again, the 193 was from 439, the total, minus 246. That's also greater than or equal to 10. Therefore, and this is a huge, big deal, you gotta write this down. Therefore, the sampling distribution of p hat is normal. If you said, therefore, it's normal, no credit. If you said, therefore, the distribution is normal, no credit, because the distribution is not normal. You would have to say, therefore, the sampling distribution of p hat is normal. And then the last one is the last S, sigma. Since they're independent, sigma sub p hat is equal to pq over n square rooted. So sigma is known. Therefore, we're going to use the Z confidence interval. It's a lot of work to do just to make a plan. But then after we make a plan, then I'm going to add the next step, which is to do. That is, we're going to do calculations. So the do portion is, I write the formula down, p hat plus or minus Z times square root of pq over n. There's the formula. Now, here's the great thing, is I know, because I showed normality, so I got this normal distribution of p hats centered at p, and my standard deviation is sigma sub p hat is pq over n, square rooted. But what I really want to do is I'm going to look and say, okay, I am going to construct a 95% confidence interval. And some of you might be saying to yourself, so 95%, that's empirical rule. So this Z, change it now to Z, the Z is 2. But I don't want you to do that. I want you to be more precise now because we're getting more sophisticated with our mathematics. So instead, I'm going to say, okay, 95%, what's left? 5%. Split between the two halves. Over here, I've got 2.5%. If I look to the Z table for the tail area, and I look for 2.5%, 0.0250, I will find that the Z of negative 1.96 is the Z-score for 95%, or for 0.025. This is the Z that goes in here. So now I'm going to do calculations. I'm going to go, okay, 246 divided by 439 plus or minus 1.96. It's plus or minus, so it doesn't matter if I have the positive or the negative. And then I have PQ over 439. All right, so I got to put those P and Q in there. So 246 over 439. Q will be the 193 over 439. It's a lot of writing to do, but we're going to do that. And then actually I'm going to go to my graphing calculator. Handy dandy graphing calculator. And I'm going to do stat over to tests. And you'll see in there, there is one of them down there. Mine is number 5 that says 1 prop z test. And I'm not going to do this until I've shown all of my other work. My 1 proportion z test, sorry, that's not what I want. Stat tests should be 1 prop z interval somewhere. Oh, there it is. So not 1 prop z test. We'll get to that later in the interval. INT. 1 prop z interval. All right, so a 1 prop z interval, and I hit enter, gives me a new screen. And it asks me for information such as, what is x? In this case, x is the number of successes. So hopefully you have your calculator and you're doing it here with me. So in this case, my successes is 246. So I'm going to type in 246. It will ask for n, the sample size. Which for us is 439. C level, that's your confidence level. For me, this first one we're going to do is 0.95. 0.95. And then I do calculate. And my screen then tells me 0.5139, comma, 0.6068, and parenthesis. It tells me what my p hat was. That's what that little symbol is, 0.56036444, etc. All right, that's 246 out of 439. It also tells me again what my n was. But what I have here is I now have my confidence interval. And then I need to write an interpretation. And the interpretation goes like this. I am 95% confident that the actual proportion of teens who would say, that would wait for marriage, all right, so the actual proportion of teens who would wait for marriage is somewhere between 51.39 and 60.68%. I am 95% confident that the actual proportion of teens who would say yes and wait for marriage is somewhere between 51 and 61%, approximately. I'd write those actual numbers that are on there, though. Okay? To do a 90% confidence interval, it changes slightly. Clear that layer. And what changes is my normal curve. And now instead of 95%, it's 90%. So what's left is 10%, split on either end is 5%. What you're going to do for the reflection response is go into the Z table, and you're going to actually find the two areas that are closest, because they're exactly the same distance away. 2 areas closest to 0.05. There are 2 numbers equally distant, one a little bit lower, one a little bit above, and I want you to write down those 2 corresponding z-scores in the reflection response. So you're going to write 2 z-scores in the reflection response. All right, so that's the first thing you're going to do. And then what I'm going to do to this is I'm going to go back up to stat tests, and I'm going to go to the 1 prop z interval, which for me is letter A. I'm going to now just go down and change it to 0.9. So now I have less confidence. So what does that mean? If I have less confidence that I'm going to capture the mean, I need to have, I'm going to have, sorry, 5214 comma, 0.59933. If I'm less confident, I've got a smaller net. I've got a narrower interval. More confidence, wider interval. Less confidence, narrower interval. If I sample more, that narrows the interval as well. These are all things that we can do as statisticians to manipulate and adjust the width of that interval. So this is sampling proportions and estimating P. So until we see you in class, Jerry, say goodbye.
Bye.
We'll see you guys in class.